The research that I've been conducting over the past 10 years or so started with benthic habitat mapping and is now transitioned into understanding how the communities change along our coastlines in Florida. So I'm not going to talk much about the Florida Keys themselves, but mostly about the two sides of the state's eastern and western coasts. So the first thing I'll do is put up a map of the Keys. So the Florida Keys has been well recognized for its ecological value since Louis Agassiz's map over 100 years ago, and for good reason. There's beautiful seascapes. It's a very vast reef system, tropical reef system. These are pictures from what it used to look like before a lot of the issues that people have talked about today, and so, rightfully so, an amazing place to talk about and to work in. However, traditionally, historically, the Keys were thought to end up here off Biscayne Bay at a place called Fowey Rocks. And so, traditionally, you know, the focus of research and all the cool things going on, fishing and all this stuff was down here in the Keys, and not much was known about the hardbottom communities along the eastern or western coasts. But obviously the reef doesn't just stop. So I've kind of set this up already, but if I showed you these pictures, you probably, and you didn't know any better, you'd probably think, oh wow, those are really nice sized corals. These are 2-3 meters in diameter corals. This is a meter stick. So those are probably down in the Keys somewhere. And if I showed you a video of some amazing Acropora cervicornis, totally live cover, vast area, you'd think, wow, what a beautiful reef. That must be in the Keys as well. And of course, you'd be wrong, because all of these things I just showed you are actually living on the nearshore hard bottoms in Miami-Dade and Broward County, right next to 6 million people. And have been persevering all of the stuff we've thrown at them over the last many years. Those large corals can be up to 300 years old. And you can see their distributions here. We find them clustered throughout the nearshore hard bottom for the large corals, and also the many dense Acropora patches that have blossomed over many years and persisted for at least 30 or so years. So the habitat mapping has kind of, and our subsequent work has kind of brought a better understanding of how the system transitions into a different climate. So the best way to view this is if we start looking at, this is a video of, do you have a mouse? You can click on the video itself. I don't know if, there you go. We're going north from Biscayne Bay. This is pretty much right at Fowey Rocks. This is Miami here. And the colors represent different habitat types along the seafloor. And you can see as we go north along this coast, the habitat morphology changes. Not only do the colors go away, which means there are fewer and fewer habitat types, but the morphology of the shelf changes. And up here off of Lake Worth Inlet, this historic reef peters out and gives way to a lot of antecedent flooded shorelines. And so the habitat maps have really helped us understand how that transition occurs and where it occurs. And looking at kind of in a biogeographic sense, South Florida has always been recognized as a different climate. In most maps, you'll see it characterized as subtropical or tropical versus a temperate environment to the north. And that transitions right around West Palm Beach, Fort Myers area, somewhere in there. That's a terrestrial designation, and you know that obviously could be moving with climate change. But so what's interesting is the reef tract also spans through that same area. And if we look at that area that I just showed you in the video, we find reduced community diversity from south to north. We find reduced stony coral diversity, reduced coral growth rates, increased macroalgae biomass, and changes in fish assemblages. So a lot of different biological changes along this system here. And so not only are the habitats discrete from one another, saying, so even in the nearshore habitats, we've described a colonized pavement, a ridge habitat, and an inner reef habitat based on geomorphology. And those are significantly different, let's say here, in terms of mean stony coral richness, but other variables as well. So we know those habitats are fairly discrete, depending on the metrics you're looking at. But there are also latitudinal differences within those habitats. So the colonized pavement community in the south is not the same as the colonized community in the north. And so if we look here at, this is an MDS bubble plot, the size of the dots, if you will, indicates the amount of certain things. These are stony corals up here, Palithoa and Gorgonians. We see up here on the colonized pavement very low values for those. And then if we look at the colonized pavement in the green area down here, we see higher values of Gorgonians and about similar Palithoa and a little bit higher in stony corals. And then in the middle, we have higher values for each of the groups. So we know there are latitudinal changes even amongst these habitat types along the coast. So one way to kind of regionalize this is to analyze the coastline, analyze the benthic habitat maps in terms of the amounts and diversity of the different habitat types along a cross-shelf transect, which this is about 750 cross-shelf transects, and basically just takes the length of habitat in each one, throw it in an MDS, and actually come up with these discrete regions based on the habitat morphology. And we've found six of those regions along our coast, ranging from Biscayne in the south with seagrass and a bunch of reef habitats, to areas up north where it's a very different morphology and habitat type. If we look at those maps, we've analyzed those maps in terms of the relationship of reef fish assemblages to the information gained from the habitat map. So basically you can look at what the reef fish assemblages associate with different aspects like reef versus bottom, different relief values, different depth values. We see that fish biogeography doesn't quite match up in some cases. I know this is going to be hard to see in the back, so I apologize. Fish morphology or fish assemblages match up with some of those same areas that we have designated from the habitat map, but in other areas they span larger different distances. So for instance, in the shallow water from Biscayne through Hillsborough, we see one discrete fish assemblage in the near shore, but in the offshore we actually see that a separate discrete fish assemblage that actually carries all the way up through the South Palm Beach region. So it really depends on the organism that you're looking at. But now we have an understanding of the biogeography shifts in fish assemblages along the coast based on their relationship to the habitat maps. And we can see if we look at the data, this is percent occurrence, tropical species on the left and more temperate species on the right. And these are, the blue bars are in the south and the gray bars are in the north. So you can see as we go from south to north, the tropical species percent occurrences are dropping off. And as we go from south to north, the temperate species are picking up. And that happens both in the shallow and deep regions. So we basically have this transition mapped out. We've done this for the entire Florida Keys. This is part of my graduate student Corey Ames's poster and a little speed talk later. But basically, we've looked at the entire assemblage. We've run a similar analysis for the entire area. And turns out that this area up here really transitions a lot depending on these discrete locations, whereas when you get down in the Keys, it's more about different habitat types, whether it's high relief, low relief, patch reef, hard bottom, and then the dry tortugas are like a completely separate group altogether. So the mechanism for this is basically temperature and geography and currents. So we have a situation where we have the Florida current that comes up through the straits. We have an area called the Bahamas Fracture Zone that occurs right off of Palm Beach, right off of about Lake Worth. And above that, the coast the coast shifts to more of a northwesterly track. The shelf opens up, and that allows for the Florida current to begin to meander more. So you get greater meanders in the current, and you can also get spin-off eddies that occur up here. And those are driving upwelling events. So you get, and this happens mostly in the summertime when the Florida current is the strongest. And so you get these intense upwelling events, which are basically keeping the tropical system from going further north. And if you look at the distribution of temperature data, the black bars here are from a site off Martin County in about 50 feet of water, and all the gray bars are all from the reef tract all the way up to Palm Beach County. And you can see that from Miami to Palm Beach County, the temperature distributions are really quite similar. And then just a few miles north into Martin County, you get this drastic shift to the south, or to the colder water. So that is basically where most of the system is, the biggest changes in the system occur. So that's all really cool stuff about the East Coast, right? So what about the West Coast? Well, what about the West Coast? We don't have any benthic habitat maps for the West Coast in the grand scheme of things. This is a map that I came up with that basically shows the Florida reef tract. There's hard bottom mapped all the way up the coast through Martin County on the East Coast. I don't know of any larger scale mapping efforts on the West Coast. If any of you guys know any, please let me know. We're trying to come up with a gap analysis to understand what areas to identify for future mapping. But similar, we've conducted some mapping up here off of Clearwater and Sarasota in the past year, and I'm going to talk about those data. This is part of a gap analysis that FWC has conducted. They've put together a GIS of all the acoustic footprints that they've been able to assemble into their GIS to then understand where to put priorities in terms of mapping. And we can see there are a lot of tiny little dots here. There's little side scan dots out here from the Fisheries Independent Monitoring, but of the vast majority of the shelf is not mapped in terms of bathymetry or high resolution bathymetry. Thanks. So in the areas that we mapped, we used aerial photography. We just identified habitat types, basically hard bottoms versus sand in a nutshell. And we found that out of these two regions right here, the red is the hard bottom. There was more hard bottom in those two regions than everything mapped in Southeast Florida. So it looks small, but this actually, and these areas are small compared to the wide shelf of Western Florida, but in reality, there is a huge amount of hard bottom out there. Probably no surprise for you folks that work there. What was interesting is we went and conducted a benthic characterizations at different sites throughout the maps, and these shapes, the blue triangles, these red triangles and green squares, match with the same shapes in this MDS plot, basically show a geographic trend in the data. So down here in these sites, these were all sites that were characterized by low coral densities and low Gorgonian densities. As you go up in the plot, you get into higher coral densities. So basically low coral density, low Gorg, higher coral, low Gorg, and then down here off Sarasota, you start getting into high density coral and high Gorgonian cover, so or Gorgonian density. So we see that shift along the coast, and it's very evident right here that there is a biogeographic shift around Tampa Bay in terms of the benthos. So a bit about the communities that are growing out there. A lot of them very small, more temperate species of corals. We focused on corals and Gorgonians because I think that's of a lot of interest for managers. But basically a lot of Siderastria, Oculina, Solanastria, and Callatocora. Fairly high densities. The grand total density was around 12 corals per meter square, which is pretty high, but they're all very extremely small. So in terms of bleaching, the condition of the Oculina, there was about 52% in bleaching, so about 52% of the corals were bleached. For Oculina, and Solanastria was about 17%. So they're really they're stressed for sure. When we were diving, the water was about 90 degrees, so I could see why they were stressed. And we also came across areas of harmful algal blooms, so that would stress me out too. But to iterate the point, all the corals were extremely small. We're not talking about the large reef-building corals in the Keys that create a lot of structure. These are all very small corals. That the average, I'd say 73% of the corals had a length of less than 10 centimeters, and 80% of them had a height less than 10 centimeters. So very small little guys, but extremely numerous nonetheless. And then here's some examples of the Gorgonian density. So you can see quite high numbers. I think the pooled total in density was about 5.5 gorgs per meter square. So basically, what I wanted to get at in this long-winded talk was to say we know quite a bit about the transition along the eastern coast. We drop from large coral. You have the traditional Keys. We still have remnant large corals that are up here growing, trying to survive in Broward County. We have cropper patches. Then we transition into more of a ridge habitat as we get to the north, and it's very temperate because of upwelling. We have a couple little patches that we know about up here of hardbottom. Indications are there's a lot of hardbottom out there, and we really don't know anything about the communities that are occurring in here or their transitions as you go north from that tropical to temperate environment. Interestingly enough, if we look at, say, reef fish modeling, these are probability of an encounter of red grouper, the juveniles, the older juveniles and adults. We see basically the red shows there's a high probability of encountering red grouper in there. Red grouper are very highly associated with hard-bottom habitats, so one would expect that there are a lot of hard-bottom habitats out there, and we don't have an understanding of their extent. So basically, in summary, I just wanted to say that the benthic habitat mapping is an essential part of understanding your ecosystem, and characterizing that habitat map can then help you understand where to regionalize it in terms of ecological priorities and ecological context even further, depending on your organism of interest. Southeast Florida shows a transition from that tropical to temperate. There are many of those resources I showed you, the large corals, the dense acropora, those were all found in the last couple years. So we didn't even know about them 5 years ago, right? So, and this is a pretty highly studied system. And so, the West Florida shelf is a big unknown, but I would say that you would find many surprises out there. So I just have one recommendation, and that's basically this whole point of this talk was to please map and characterize the Western Florida shelf so we can start to understand what's out there and the amount of those resources. So, thank you. Oh, the acknowledgements.
So Brian, you used up all of your 20 minutes.
I did. I always do.
But that's not a problem. Can we get the house lights up and the speakers move down front, and to the extent that you want, we can do direct